Just whatever board I'm writing on, make sure we capture. I'm going to write over here for a little bit, okay?
You're recording already?
Yep. All righty, we get 3, we get 5, we get 9, we get 13, we get 16 people. Naum is in the house. Side conversations are done. I'm not going to repeat that because I do not repeat myself. Okay, so somewhere in your notes, maybe on a separate sheet of paper, I would recommend that you draw a function. I just want to do a quick recap. Carlos, we're moving on here. We've got a function. Newton, back in the day, said, gosh, it's really important to me for some reason to find the slope of this line. What kind of line? Tangent. Tangent line. Jose up front, why is this a tangent line? The line touches the curve once, right? Touches the graph once, touches the curve once. Saying that anyway is fine. Now, one thing I want to be clear. Some people in like second period said, but wait a minute. If this is a line, lines go on forever, right? And what if the line crosses the curve up here? Does it now become a secant line? Technically, yes. But I'm really just talking about what's happening around this point. So if in your mind you need to think segment, tangent segment instead of tangent line, we're going to call that good. Everybody okay? What I want though, if I label this point A comma f of a, I want to find tan at x equals a. And for those of you thinking right now, gosh, didn't we do this last week? Yes, we did. I just want to do a recap here. I want to get some hands. What's the formula? There is a formula you just got to know. Find slope of a tangent line at x equals a. I see one person. I see 2. I see 3. There's 16 people in the room. 3 people out of 16. Know the formula. I'm a little bit worried. Kevin, help me out here.
Limit as x approaches 0,
A.
fx minus f over x minus a.
Limit as x approaches a, f of x minus f a over x minus a. Ashley, are you okay there?
Oh, yeah.
I'm really thinking there are some folks that need to find a new seat. Because side conversations driving me nuts right now. Slope of the tangent line at x equals a, limit as x approaches a, f of x minus f a over x minus a. It's the formula. This is one of the formulas that you need to know. As important as the formula is, I'm also interested in the story. Where does this formula come from? Why this formula to find the slope of the tangent line? And it all goes back to the graph. It all goes back to what Newton told us to do. Abraham, help me out a little bit. Why this formula? Where's this coming from? We've got this point over here, our point of tangency. I want to find the slope of the tangent line. How do we go about finding the slope of the tangent line? What did Newton tell us to do? You need a secant line, right? To make a secant line, you need another point. And I'm just going to label this other point x comma f of x. And I'm going to connect these 2 points with a line. And I heard Jackie and some others already say, oh, that's a secant line. I can find the slope of the secant line, f of x minus f of a over x minus a. No surprise, we're good with this. That's what this part of the formula is telling me. This is secant. The reason for the limit as x approaches a is Newton said that red line is not going to give me, oh thank goodness, that red line is not going to give me the slope of the black line. What do I need to do, Caleb? If I want to get to the slope of the tangent line, what do we need to do? Get the second point as close to the first point as possible. So if we get over here, is that good enough? I mean, that's going to give me a secant line, and you might say, well, that line is better, has a better slope, but Jose, is that the best you can do?
No.
Oh, not Jose Beto, sorry. Is that the best you can do? Could you get closer?
Yes.
How close?
Really close.
Really, like over here close? Like really close.
Yeah.
Our notation for get really close, Pedro, is limit as x approaches a. Get those 2 points as close as you can get. And so close you can't even tell them apart anymore. So close it looks and it feels like 1 point. Is everybody good with this? This is the big picture. This is the behind the scenes. Most of you are really good using the formula, but I also want to make sure you understand conceptually what's going on. So this is formula number 1. This is going to tell you the slope at 1 point. So I say, hey, go find the slope of the tangent line at this particular point. Everyone's going to use that formula. There's another one that we talked about that also tells you slope of tangent line at x equals a. It looks a little bit different. It's f of a plus h minus f of a all over h. It looks different. It drives a little differently. We take the limit as h goes to 0. But ultimately, it's still the slope at 1 point. So if I say go find the slope of the tangent line at 8, you can use the formula. But then I say, hey, go find the slope of the tangent line at a different point, you got to go through the process all over again. And it's a lengthy process. So instead, there's a general one, and this is called the general form. And this is the limit as h approaches 0 of f of x plus h minus f of x all over h. We talked about this one. We talked about it rather quickly at the end of the day on Friday. Your answer is actually going to be a function. It's not going to be a number, but it's going to be a function. It's going to have a variable in there. But what this tells you is the slope at every point on the curve. At every single point on the curve can be found using this formula. Much like me, it's more powerful. It can do all the things. You're asked to find the slope of the tangent line at 4 different points. You use this formula 1 time. You plug in 4 different numbers. It's much faster. Big picture, is everybody okay? Does anybody have any questions at all? Because this is foundational to everything that we're doing in the course. Everybody's good? Okay, so if you're good, then the homework tonight, assignment number 15, all those problems, everything has to do with this. Now what I want to do is I want to move forward. So here comes some new stuff. You're going to do a little bit of writing. We're going to get an opportunity to practice the formulas. Life is going to be good. So I'm at the bottom of page 42. You're definitely going to want to take out some colors, I think. We're going to have a conversation about your life before you met Mr. DeRozier, and a conversation about life now that you have met me. Now, Jose, that you're here. Jose, I'm going to someday figure out the difference between you and Beto. I thought I had it today. I didn't. I had to whisper to Roberto when you walked in. I'm like, hey, Roberto, help me out. Who's that? Is that Jose? And he said, yeah. Jesus. Lied to me? I asked if that was Jesus. Oh, man. Okay. Anyway, we're going to figure it out. I'll get the video. I'll replay the footage, and we'll see if Roberto was lying to me.
It wasn't on camera.
It wasn't on camera. Man, I got to up my game. Back in the day, before you met me, think Algebra 1, Algebra 2, pre-calculus. You were asked, you were given diagrams like this. You were given 2 points on a curve. They were connected with a line. And I'm pretty sure back in geometry, Algebra 2, pre-calc, we just said line, and line was good enough for us, right? But Pedro, you know, what kind of line is this red one? It's a secant line. And I might ask you to find the slope. Slope was a word that we used a lot. There was another word that you used in Algebra 2. You'd call it slope. You'd also call it, anybody remember AROC? Rate of change, but be specific. Average rate of change. This word average is really important. What we're saying is that on average, from this point to this point, what happened with the function? Now, formulas for average rate of change, just call them out. What formulas do we have here?
Isn't it y equals mx plus b?
Not y equals mx plus b. That won't give you the rate of change. That's a formula that involves
Y
slope.
two
y
minus y1
y2 minus y1
over x2
minus x1.
over x2 minus x1, right? That's one formula that we know for rate of change. Another one? Rise over run, right? It's exactly what you do in the bell rings. You rise and you run. Okay, any other ones? Ah, that's a good joke, I know. y2 minus y1 over x2 minus x1, rise over run. Any other ones? There's another one. The one with the triangles? Change in y over change in x. Is everybody 100%? These are all the same thing? One? These are all the same thing. The other one, though, is f of b minus f of a over b minus a. A and b are the beginning and end points of the interval. F of b and f of a are the y values. So this is just change in y over change in x. And everybody's good. Everybody's got this under control. There was also a sentence that you had to write in Algebra 2. And I'll tell you, it showed up on every common assessment you've ever had. In Algebra 1, it said, find the average rate of change, and then explain the meaning, write the sentence. And the sentence had to look something like this. From x equals a to x equals b. The function, and then you had to say something about the function. The function is, right, it's either increasing or decreasing at an average rate of, now you put in whatever the number was, right? Whatever number you get from your average rate of change. And then there are the units. It was average rate of some number, and then units for, I'm just going to abbreviate the dv. Do you guys remember dv? Dependent variable, divided by the units for the IV, the independent variable. And watching you all, sort of the hundreds of pre-calculus students last year, we're always confusing our dependent variable and the independent variable. The independent variable is what you have on the x-axis. The dependent variable is what you have on the y-axis. But this is what the sentence has to look like. From x equals a to x equals b, the function is increasing or decreasing. You tell me which one. At an average rate of the number, but no signs here. Units for the dependent variable over the units for the independent variable. This is the deal. This is what we do. Now, something that's really important. Let's say, well, what are we going to get for this particular secant line? We're going to get a positive or a negative? Easy, we're going to get a negative, right? So here's the thing. You know that for this particular line, that AROC is negative. So what's the function doing? The function's decreasing? Always decreasing?
No.
Always decreasing? No, I can see from the graph that there are places where the function increases and there are places that the function decreases. Are we good? That's why this word average is so important. What we're saying is that if we look over the entire interval, there might be places of increase, there might be places of decrease, but on average, we've decreased from where we started to where we ended. And I think everybody's okay with this? This was before me. Ta-da! I show up on the scene with Newton. No, I'm not going to jump again. It makes me jiggle, and I don't like jiggling. Okay, now we've got this line. What kind of tangent line? Oh my God. Tangent line. And we used to talk about this thing called average rate of change, where we said on an interval, Eric, what happened? On average, we decreased. I'm not talking about average. I'm not talking about an interval. I'm talking about at a point. At one moment in time, what's happening? What's the function doing at this moment? And this is why we use instantaneous rate of change. At an instant, are we increasing, are we decreasing, or are we constant? For this particular problem, for this particular graph, slope of tangent line, positive or negative? Positive, right? Easy peasy, I can see from the graph. Okay, I want to get a couple of notations. One way that I'm going to say instantaneous rate of change, tan, at x equals a. We've seen this one before. There's another one. There's another one that you guys know means tan. What's another one? There's one more that you know.
Isn't it
Another notation that we use for derivative. Pedro. There you go, f prime of a. F prime of a. Here's another one that you don't know. dy over dx at x equals a. Kevin, it means the same thing. It means you're going to go find the derivative. Any guesses what the d stands for? No, derision, dummies. Derivative. It's the derivative of y with respect to x. That dy dx notation, it's like the delta. Okay? Here's another one. If you were growing up in India, they might use the dot. They use f dot. Those of you that are going to go off and study engineering, they use dot notation sometimes as well. But it just means derivative. I don't use this one very much. They're also going to do f prime of x with the vertical bar at x equals a. They all mean the same. They all mean Beto, whoever you are back there. One of the four of you is Beto, I'll figure it out. Jesus is going to be a mystery for a while. All five of these mean go find a derivative. We're good? Let's get the sentence. So let's start the sentence. What's going to be different?
It's no longer how to have the average.
At x equals a.
Oh, that.
It's not an interval anymore. It is a moment in time. Guess what? That is the only change. At x equals a, the function, you're going to tell me what the function is. The function is increasing or decreasing. Here comes another change. At a rate. Don't say average rate. We're talking about it at an instant. You could also get fancy and say at an instant rate of, you're going to give me your number, and then it's going to be the units for the dependent variable over the units for the independent variable. I'll stop talking and let you guys get caught up. Sentence is the same as it was in Algebra 2. The difference is, at a point, over here life was over an interval. And I think everybody's good. All right, so with that said, I want to go back to Algebra 2. And this problem actually came out of an Algebra 2 test. So you guys may remember, you may have seen this before. Top of page 43. And I get Pedro in a long, strong, dramatic voice. Can you read the introduction to this problem?
Since 1940, economists have been keeping track of the number of metric tons measured in thousands of edible fish produce that is exported every year. The results have been summarized in the table below.
Okay, so we're looking at fish export measured in thousands of metric tons every single year. Back in Algebra 2, the question might have been, find the average rate of change from 1950 to 1960. Algebra 2 question, not a calculus question. I want you to find the average rate of change on the time interval 1950-1960, then using the correct units, explain the meaning of your answer. Go for it, see what you can do. First three people to get the perfect sentence get a Spider-Man sticker. We're talking big time, these are big stickers. 4, 8, 12, 14, 17.
The year is a Y, right? Yeah, the year is a Y. My bad. It's gonna be 2. It's gonna be 2 over 10. Negative 1 over 5.
Getting the right number does not get you the sticker. You need the number and the perfect sentence. Good.
What does it mean by units for the?
I have it.
Yeah, over the thing.
A year over. It'll be
So how would
number
you
of
able to
fish over.
sentence?
It'll be number of fish over the year.
So average of 1 of like negative 1 over 5. The one I put. After I put the average of negative 1 over 5, what do I put for this? So I just go fish over.
Yeah. No, it'll be a year.
Zero. Fish over year. That's my sentence. Bet.
Okay, so from doing a quick lap around the room, there seem to be 2 popular answers in the room right now. It's either 50 minus 52 over 1960 minus 1950, or 1960 minus 1950 over 50 minus 52. How many of you guys have the first one? 1, 2, 3, 4, 5, 6, 7, 8, 9. A whole bunch. How many of you guys have the second one? Yeah, okay, liars. Name's like, ooh, who did that? Name, what's the mistake? Which one's the right one?
The one on the left,
The one on the left. What's the mistake that the person on the right did?
they put the years on top.
They're putting the years on top, and in the table, right, we want to think about the years as the X and the fish export as the Y. The X is your independent variable, and the fish export is the dependent variable. The fish export depends on the year. The dependent variable depends on the IV. So if all goes well, you get negative 1/5. I have not seen the perfect sentence yet.
I got you, Mr. I got you.
Nope.
It's fish.
Yeah.
Export, not fish.
Fish export.
Yes.
Right here?
It's fish export, not just fish.
Not perfect.
Fish export.
Close, closest I've seen so far.
Mr.
Okay, closer than Roberto's, but not perfect.
Was that fish export over here?
Oh no!
Is that what it is?
No. There are so many close calls. No. So close, not good enough. No. I have not seen in 18, 17, because Ivan's not here. No. This is what happens at reading day. Oh my God, this happens at reading day all the time. Nobody knows how to write the sentence. Nobody knows. From 1950 to 1960, before you're like, I got that. Yeah, I know. Everybody's got that part. From 1950 to 1960, what's happening? The function is what a lot of you have written, but you have to be specific.
Number of fish export.
What is the function measuring? The fish export. What's it doing? Is decreasing. Good news. Everybody and their mama had decreasing. Everybody had decreasing. Everybody had from 1950 to 1960. The fish export is decreasing. Here's what everybody else had. At an average rate of what?
Negative 1 over 5.
Stop saying negative. You already said negative. Hey Zeus, when did you already say negative?
That's like,
As soon as you said decreasing,
double
you spoke
negative.
negative.
that's a double negative.
At an average rate of 1/5, and here's where I did not see a single perfect paper. I need units, not fish export, units and units. Units for the dependent variable. What are the units? Thousands of metric tons. You have to give me the entire unit. That's the unit for fish exports. Now I go to the denominator, units for time. Year. There were a lot of you that were like 80% close. Nobody had the whole thing. Okay, are we good? Can we get out of Algebra 2? Excellent. One up front. Take us to calculus, son. Can you read the introduction there? You got this one?
Let me t equals 60 minus 3 square root of t. Represent the continuous function which can be used to approximate the data in the table above. Where t measures the number of years since 1940 and equals t represents the number of metric tons measured in thousands of fish produced exported that year. Using correct units, explain the meaning of the instantaneous rate of change at t equals 16.
Perfect, Juan, thank you so much. So this is the calculus question. Rather than data points, you've got a function. And there is a phrase in here that tells you exactly what to do. What's the phrase? Instantaneous rate of change. As soon as you see instantaneous rate of change, here's what I hope happens in everybody's brain. Instantaneous rate of change. Oh, you know what he just asked me to find? Tan. Good, go find tan. Tan at t equals 16. As soon as you see instantaneous rate of change, that's what you need. Okay, get me the setup, show me what you can do. And remember, I'm picky. Well, my daughters know how picky I am. Jose's off to a good start. Pedro thinks he's off to a good start. Eric's having some deep thoughts. Whoever this young man is over here, he might be off to a good start. Who knows? I'll come back later this year. We'll figure it out. It's all right. I'll get it. I'll get it. Trained professional here. Go away, flood insurance people. Closing the achievement gap here. Okay. Okay. Good news. Not a single person in this room right now has written this down. Take a minute. Take a minute. Look what I just wrote. There are at least 3 things wrong here. There are at least 3 things wrong. Carlos, what's one thing you see that's wrong?
You put f of 16, and that's f of a, but a is not 16.
A is not 16? Actually, A is 16. A is 16. That is not what's wrong here. Delia, one thing that's wrong.
The notation, it should be t, not x.
Right. What's the variable that we actually care about in this problem? It's not x, it's t. So t, t, t. Yes, I am going to be that picky, and so will the College Board. There is another problem. There is another fatal mistake. Roberto, what is it?
Instead of f, it should be a function of e.
How do you know that?
Instead of
That's the name of the function. It's not f, e. Limit as t approaches 16, e of t minus e of 16 over t minus 16. Yeah, that makes me want to suck my teeth too. Some of you guys are, oh. Yeah, I know. You have to be that precise. Here's the good news. After this, most of you knew what to do. Limit as t approaches 16, e of t, 60, minus 3 square roots of t, minus, I like my parentheses, 60 minus 3 square roots of 16, over t minus 16, life is good. Some people went and said, you know what, back with this, I know what this is. Square root of 16 is 4, times 3 is 12, 60 minus 12 is that 48? That's good. Limit t approaches 16, 60 minus 3 square roots of t minus 48 over t minus 16. I've seen a whole lot of folks successfully get to 12 minus 3 square roots of t over t minus 16. That's great. That's great. And some people have made it past this. You know what to do. How many of you are pretty convinced you know exactly how to evaluate this limit? Kaylin's feeling pretty good about evaluating this limit. You know what to do? Evelyn looks maybe? No? Kaylin, what are we going to do? How are we going to evaluate this limit? So I heard you say multiply by the conjugate. What is it that you're seeing that's telling you I'm going to multiply by the conjugate? It's that square root, right? The square root is the sign. And so you might say, hey, let me multiply by 12 plus 3 square roots of t. And 12 plus 3 square roots of t. Love it. Okay, let's finish this off. Limit as t approaches 16. 12 minus 3 square roots of t times 12 plus 3 square roots of t. Go to the side, do the box if you need to. But Kevin, you know what's going to happen here, right?
Yeah.
What happens?
It's really going to cancel each other out. That would be 9.
I agree, but let's focus on the first part. 12 minus 3 square roots of t times 12 plus 3 square roots of t. It's this guy squared minus this guy squared. So 12 squared is 144. Thank you for the one person out of 18 that was pretty confident that 12 out of 12 times 12, 144. 3 square roots of t times 3 square roots of t is 9t. In the denominator, t minus 16, 12 plus 3 square roots of t. Good? Not done. What else could we do? The numbers are a little ugly. You could multiply out the bottom, but I will tell you the secret is that we never actually multiply out the bottom.
Can we just plug in 16?
The 16 is the problem, right? The problem is that you get 0 in the denominator when you plug in 16, and I bet you're getting a 0 in the numerator when you plug in 16. If only there was something going on here. Hi, Beto, what's up?
Can you divide out 9?
Okay, there's a better word, though, that I was hoping you were going to say. Not divide out, it's an F word. Be careful.
Factor out.
Factor. Factor. You want to factor out. Limit as t approaches 16. Kevin, you were going to say factor out, weren't you? Okay. T minus 16, 12 plus 3 square roots of t. And now we cancel. T minus 16, 16 minus t.
No.
What's wrong?
Because the first one is positive 16, and the one
With a positive 16, negative t, and then the second one?
is positive t and negative 16.
So what happens when they cancel?
We do the negative.
Yeah, it actually introduces a negative. When they divide out, you actually get a negative one, not a positive one. So your final answer, limit, you guys are really getting good at this. Limit as t approaches 16, negative 9 over 12 plus 3 square roots of t. Now I think we can safely plug in 16. 1, 12 plus 3 square roots of 16, which I think is negative 9 over 24, which is negative 3 over 8. If this was the test on Friday, getting here, honestly, would probably be worth about 3 points. Coming up with that average rate of change would be worth like 3 points out of 4. Here comes the last point. Get me the sentence. get me that sentence. I want the perfect sentence. I have given out no Spider-Man stickers. I have 4. I'd love to give out 4 Spider-Man stickers. Use your notes if you need to. Pick a Peter Parker. Three stickers left. Nice. Smart and good looking, just like me. Pick a Peter Parker. 2 Spider-Man stickers left. Pick a Peter Parker. There's only 2 left. Looking for one more. One more. Imagine this at 16 minus 8. This is what you got. The function's gonna go bye-bye. Not the function. This is the last one. At t equals 16, the fish export is decreasing at a rate of -3/8. No! Pedro! At t in the year 1956, the fish exports are decreasing at a rate of 3/8 thousands of metric tons per year. You can't pick a Peter Parker because you got the last one. Ooh, sweet baby Jesus. All right, and for all the friends that did not get it, here we go. At t equals 16, the fish export. What's it doing? What's that fish export doing?
Decreasing.
Decreasing. Keep it coming. Decreasing. At
a rate of 3/8 thousand of metric tons every year.
1,000 metric tons per year. That is the perfect Peter Parker earning answer. It's a whole lot of work for that one little point. And all my friends who had -3/8, you forfeit the point even if everything else is perfect. Sorry. All right. So you guys need a challenge, I think. So let's go over to page 45. Okay, page 45. Excellent. We've got 10 minutes. Page 45. It's a new situation. I need to make a change to this. I didn't realize it until earlier. Shame on me. Shame. Someone should walk behind me with the bell and say shame as I walk.
I was like, oh my god.
I know Miss Blakely at East End watches Game of Thrones. She's got good taste. All right. In part B, G prime of 27 and G prime of 50. Okay. So take 2 minutes, read through this problem, see what you can do. Ashley, are you okay? I see you. You look like you're trying to hide, but I see you. Ashley? Just don't write. The one that I just went from 45 A and B. A and B. Be careful, last class did not understand part A. If you need to use a calculator, that's okay. I have a master's degree in mathematics. That actually might be the way. I usually sit down and type.
Like just whatever number comes up to you.
No, I mean I made this in a very particular way. There's some things I wanted to have happen. No. Because you can, I mean, anybody can sit down and type anything, like I made an equation. But I needed specific things to happen. That's a little tricky.
6 miles per gallon.
That's what happened on Friday.
Oh, quiz.
This car can travel at 27 miles per hour this year. Yeah. 6 per gallon, miles per gallon. When I eat it,
Good. Keep going. Keep going. Keep going. Okay, for any of the friends, and there are some folks who have done a good job, keep going. I want to attack this problem real quick. There's two different variables happening here. We've got V and we've got G of V. What is V measuring?
Velocity.
Okay, hold on. Hear the question again. What is V measuring is not the same as what units am I using to measure. What is V measuring? This is speed.
velocity.
What's true? True. But moving on. G of V. What is G of V measuring? Go back and read the problem. What is it measuring?
Fuel efficiency.
Fuel efficiency. Fuel efficiency, for those of you that are maybe not as familiar, like when you go and you buy a car, or if you watch a car commercial, they advertise how efficient the car is by how many miles per gallon you get. And they talk about like city driving versus highway driving. City driving, a lot of like stop and go, you're in traffic, you're less efficient in the city, whereas if you're on the highway and you just go, you're much more efficient. So they normally post both numbers. So now the question is, what are the units that I'm using for speed?
Miles per hour.
Miles per hour. And what are the units for efficiency? This is miles per gallon. So in part A, compare the fuel efficiency if I'm traveling 27 miles an hour to the fuel efficiency if I'm traveling 50. Oh, you can just leave those on the desk. Thank you. If I'm traveling 27 miles an hour, most folks just plugged it in to the top one. 27 plus 9 is 36. Square root of 36 is 6. If all goes well, you get 26. So if I'm driving 27 miles per hour, my fuel efficiency is 26 miles per gallon. G of 50 is negative 1 over 20. 50 minus 40 squared plus 25. 50 minus 40 is 10. 10 squared is 100. Negative a 20th of 100 is 5. Negative 5. This should be 20 miles per gallon. No calculus was done there. There was no calculus there. That was just read the problem and go. Part B, finally, go find G prime of 27. I want to be a proud papa.
Oh, that wasn't deep.
For this particular one, you're more efficient at 27.
It's only like 5 or 7 minutes.
You get 1 point just for having the right setup. Oh, get me that right setup.
Okay, so we're struggling.
Because they can't subtract from it. What does it mean by that?
By what?
Determine the correct
Anything you did, but remember, like a dispute or something.
He wants you to make sure that you write the right thing.
Oh, what's this? Okay, so this one we just have to solve. This is where you write the response to it? No, no, this is where
It's like what we just did.
Basically, solving
It's basically what we just did.
This is-
Oh, no! No!
So what is it? Like the value.
Oh, this tangent.
Naum is probably going to come up with the right. Oh no, you're doing even worse than him. Look what you've done to this good girl. I like this, but I don't love this. You're not finding slope of tangent lines. That is perfect. We should all nap more often. That's the moral of the story here.
It's proven. Studies have shown
All right, we've only got 2 minutes, and I want to pull everybody back together. So just stay with me for a second. G prime of 27. Everybody seems to know we're trying to find slope of tangent line. Like, we're good. The problem is you got to get the right formula. The limit has what's approaching 27? The G of V minus G of 27 over V minus 27. You have to get the variables right. So limit as V approaches 27, G of V is negative square root of V plus 9 plus 32 minus 26 over V minus 27. I'll tell you, that gets you the first point. Your final answer, if everything goes well, is negative 1/12. Okay, that is a huge leap of faith, I know. But I have not lied to you to the best of your knowledge. It's negative 1/12. Write the sentence. Miracle happens in this blue. Get me that sentence, get me that sentence, get me that sentence. At V equals 27, what's the function? The fuel efficiency. What's the fuel efficiency doing? Decreases at a rate, right, this is the easy part, at a rate of 1 over 12. Now, units in the top, units in the bottom, don't blow it. Units for the dependent variable is miles
per hour and miles
per gallon. The independent variable is the velocity. The dependent variable is the fuel efficiency.
So
So
gallon and per mile.
miles per gallon,
Miles per hour.
miles per hour. They're
Miles
crazy
per gallon,
units,
miles over miles per hour.
but it's important. Tonight's homework, assignment number 15, all the problems. It has nothing to do with instantaneous rate of change. See you later.
I do stop.
I'll post the video.